On Tuesday, November 19th, a cargo jet Airways Boeing 767-300 overran Vancouver's runway 8 left by 1,800 feet after declaring a pan-pan for a leading edge slat asymmetry. Here's what we know so far. My name's Juan Brown. You're watching the Blanco Lirio channel. I used to fly the 767 quite a bit, and looking at this picture, we can tell a couple of things. First off, it's been raining quite a bit up there in Vancouver, and the ground is very wet, so the plane is sunk up to the axles in mud, and I believe the nose gear is simply sunk into the mud rather than folded up or busted off. Second, we can tell that the crew was able to get out of the aircraft without having to do an emergency evacuation by simply climbing down the ladders, which I assume were provided from the firefighters. Here on the wing, we can see the leading edge slats appear to be fully deployed, and the trailing edge flaps appear to be somewhat deployed. I'm not sure what that flap setting is just from looking at this picture, but it does appear that the trailing edge flaps were able to be deployed for this landing. The reversers, the thrust reversers, have been stowed, and there's no signs of any spoilers on top of the wings being deployed. Now, these conditions can change after the aircraft has come to a complete stop and has been shut down, but that's the condition we see the plane currently. Going next to the Aviation Safety Network, Tuesday, 19 November, 1:29 local time, Cargo Jet Airways Flight 2387, a Boeing 767-300 cargo airplane, suffered a runway overrun after landing on runway 8 left. Runway 8 left is 9,941 feet long at Vancouver International Airport, British Columbia. Here they say the nose landing gear collapsed. Preliminary information indicates that the flight crew had declared pan-pan prior to landing, reporting a flaps problem. We'll check the ATC audio on that. We'll see where the miscommunication came from that. And that they would land at a higher speed than normal, which is normal for these sort of malfunctions. ADS-B data suggests the airplane landed with a ground speed of 173 knots and overran the end of the runway by 1,880 feet. With a leading edge slat asymmetry or trailing edge flap problem, you may very well end up with an approach speed that is at least 30 knots above your normal approach speed, which would be about 173 knots. Looking at the ADS-B data from ADS-B Exchange, looks like the flight departed Hamilton, Ontario, Canada, and came into Vancouver for a left downwind entry for runway 8 left. We'll review the ATC audio, but it sounds like this crew only gave themselves about 10 minutes to work this problem out. As the problem arose here on the downwind pattern, they got an extended downwind and a delayed vector here for a sharp right base entry to about a 14-mile straight-in final. Nice stabilized approach into runway 8 left. Looking at the ADS-B data here on FlightAware, we can see the bomb cyclone off of the west coast here, which resulted in winds reported by the tower at the time of landing as being just 050 degrees at 7 knots. And if we look at the last few data points from FlightAware, we can see the increased approach speed of about 165 to 170 knots, which you would expect for some sort of a flap malfunction or slat malfunction, and a vertical descent of about 900 to 1,000 feet per minute. Because of the higher approach speed, you will get a much higher rate of descent. But still, all very indicative of a stabilized approach for some sort of a flap-slat malfunction requiring a higher landing speed. One of the first things investigators will need to determine is exactly where did the jet touch down at. It's imperative in these sort of emergencies that you touch down right at the beginning of the runway. Here they are at their 173 knot ground speed right over the end of the runway. We can't tell from this ADS-B data exactly where they touched down, but here they are at 124 knots at the end of the runway, overshooting the runway by over 1,800 feet. Here's a look of the runway on Google Earth or Google Maps. Here's the end of the runway, and here's where they approximately got her stopped before the ILS antennas here at the end. And what I don't know is this material right in here. There's been some work being done recently here at the Vancouver runways. Is this EMAS material? And I see no photographs yet of the jet passing through this material. Was this EMAS operational at the time, or was the jet simply too fast and too light on its feet to penetrate the EMAS if this EMAS material was in place? EMAS is that new safety device, engineered materials arrestor system. It's soft concrete that allows the heavy jets to crush into and help slow them down and stop them from these kind of gross overruns beyond the end of the runway.
Arrival, good morning. Cargo Jet 2387 Heavy, out of level 210, descending 10,000 for 0 right, 0 left, correct. Cargo 2387 Heavy, Vancouver, arrival landing 08 left, altimeter 2900 under 08 is X-ray.
Out of 210 for runway 8 left.
Okay, we've got X-ray, 2900 under 0, Cargo Jet 2387. Cargo Jet 2387, cancel the speed at landing. So cancel the speed at landing, Cargo Jet 2387.
Cancel the speed at Lenny because it's 1:30 in the morning. They can just come on in real fast.
Cargo Jet 2387 descends 5,000 unrestricted when ready. Okay, descend 5,000 unrestricted, Cargo Jet 2387.
Descend to 5,000 unrestricted.
Cargo Jet 2387, turn left heading 170. Just give us a moment, we'll call you back.
Okay, he's clearing him for this left base turn.
Cargo Jet 2387, would you like to close the star via Venlo MCAM?
Negative. We have a flight control problem. We have to run a checklist.
So I don't have my 4-flight Canadian subscription, but he's saying, do you want to turn left and go direct to MCAM, which will put him on about a 14-mile straight-in final for 8 left.
Radar vectors downwind here.
Cargo Jet 2387, roger. Flight present heading.
Present heading, Cargo Jet 2387.
So they're going to extend their downwind leg.
2387, I'd like to keep you close to the airport if possible. Turn left heading 170, and I'll continue to vector you as long as you need. Okay, left heading 170 for Cargo Jet 2387, thanks. And Cargo Jet 2387, would you like a turn to final or further vectors for delay?
Forward vectors for Cargo Jet 2387.
Cargo Jet 2387, roger. And do you need me to roll the trucks for you, or are you declaring an emergency?
No, just pan. We have a leading edge flight asymmetry running the checklist. Yeah.
Let's hear that again. No, just a pan. Let's see what exactly problem he's got.
And Cargo Jet 2387, would you like a turn to final or further vectors for delay?
Forward vectors for Cargo Jet 2387.
Cargo Jet 2387, roger. And do you need me to roll the trucks for you, or are you declaring an emergency?
No, just pan. We have a leading edge flight asymmetry running the checklist.
A leading edge slat asymmetry, not a leading edge flap asymmetry, but the slats. There is no such thing on the 767 as a leading edge flap asymmetry. There's no flaps on the leading edge, only slats.
Yeah, we can bring out the fire truck just for precaution.
Roger.
So he's declaring a pan. Remember, a pan is short for possible assistance needed versus a mayday where it's an urgent situation and requires immediate attention. So good call on behalf of the crew.
And Cargo Jet 2387, say again the nature of the emergency. I missed it there the last time.
Just the flight control problem. We have a flat symmetry.
Again, he reiterates it's a slat asymmetry. More on that checklist in a minute.
Flat symmetry, you said?
Affirm. Just flight control problem. We have a flat symmetry.
Flat symmetry, you said?
Affirm. Just leading edge flat symmetry. Coming in with a slightly higher airspeed.
will be coming in with a slightly higher airspeed. It sounds like the tower read back flaps versus slats, and that may be the source of confusion in the media versus this issue, because everybody in the media is reporting it as a leading edge flap asymmetry when it was not.
Okay, Roger. And Gauge 2387, have a few more questions for you when you're able.
Go ahead, please.
Gauge 2387, how many people on board and how many pounds of fuel?
So we've got 3 board, and at this time we've got 23,000 pounds of fuel.
Confirm 23,000 pounds of fuel?
That's correct, sir.
Roger. Any dangerous cargo?
None.
Roger.
So 23,000 pounds of fuel. Yeah, that's their normal reserve fuel. They're coming into their final destination. Sure, they do have enough fuel to do a short diversion, or they got plenty of fuel to go into a holding pattern and sort this situation out. They are certainly not tight on fuel at this point.
Sure. 2387, turn left heading 110.
Left heading 110, Cockpit 2387. 2387, we're ready for the approach now, sir.
Cockpit 2387, Roger. Turn left heading 050.
Heading 050, Cockpit 2387.
Cockpit 2387, is it all the flaps you're having an issue with, or just a particular one?
It's just the leading edge flaps.
Leading edge flaps, Roger.
Just the leading edge slats is what the, I presume, the first officer is saying, but the tower continues to read back leading edge flaps.
And Cockpit 2387, request to route back to MCAM.
Cockpit 2387, you're looking to join at MCAM?
Yes, sir.
Cockpit 2387, proceed direct MCAM.
Direct MCAM for Cockpit 2387, thanks.
And Cockpit 2387, that will be a steep intercept angle, is that okay?
You can give us lower, actually, we would appreciate it as well.
Say again?
If you could give us lower.
Okay, Cockpit 2387, descend at 2,000 till MCAM. You're cleared for the ILS Zulu, runway 08 left approach.
Okay, we descend 2,000 MCAM, and we're cleared for the ILS Zulu, runway 08 left approach, Cockpit 2387.
Roger.
Okay, they're cleared for the ILS Zulu 8 left via MCAM, which will put them on about a 14-mile straight-in final. So you need at least a good 10-mile final stabilized approach for these flat slat asymmetries. But they're talking about this. It was kind of a sharp 90-degree bend onto the approach, but they managed that just fine. And the crew was smart in requesting lower because they know they're going to be needing to come in at a slightly flatter approach for this flap-slat asymmetry at the higher airspeed.
Cockpit 2387, just be advised that's about an 80-degree intercept angle. It's going to be a sharp turn.
Okay, that's copy, sir, thanks.
Cockpit 2387, contact Vancouver Tower 119.55.
Tower 119.55, Cockpit 2387, thanks for the help, sir.
You're welcome.
And Vancouver Tower, good morning, it's Cockpit 2387 Heavy, start time. We're established on the ILS, 08 left.
Alright, that's 2387 Heavy, Vancouver Tower, wind 050 at 7, clear to land, runway 085.
Winds 050 at just 7 knots. So just about a 6-knot headwind.
That's land 08 left, Cockpit 2387.
North ground, red 14 plus 1.
Red 14 plus 1, guys.
Red 14 plus 1 is main apron. We're just on Juliet Alpha heading towards our standby location, which will be Quebec. We'll enter in at whatever location reasonable, but requesting Quebec, red 14 plus 1.
Red 14 plus 1, ground understood, proceed by Tango Mike, Quebec.
The red call signs are the emergency responders getting into position. Remember, he did declare the pan, but he also suggested, go ahead and roll the trucks just as a precaution.
Tango, Mike, Quebec, red 14 plus 1.
And red 14 plus 1. That traffic is 4 miles final. They are going to be coming in fast, flat.
Roger that, flap issue, red 14 plus 1.
Ground, good morning, red 9 plus 3.
Red 9, please, ground.
Red 9 plus 3 on the west side, just to let you know, red 9 will be the lead vehicle.
Red 9, ground understood, traffic down 2.5 miles final. Again, these flat issues are going to be coming in quite swift.
So The ARF crews know that the aircraft is coming in with a flap issue, and they will be coming in at a faster than normal approach speed.
Copy that. Thank you for Red 9 plus 3. I'm Red 14 plus 1.
Red 14 plus 1, yeah.
Red 14 plus 1 at Quebec, short of light, standby location.
Stop on the runway, cargo jet, you can't stop on the runway.
Okay, cargo jet can't stop on the runway. He's trying to get a word in edgewise between all these ARF crews talking on the radio at the same time, but he's now going to declare a mayday.
Alright, that's 2387, understood.
Runway, Victor, come.
Red 14 plus 1, okay, so you're just exiting the runway now, proceed on to runway 08 left. 14 plus 1 ground, you are cleared on to runway 08 left to find the aircraft there at the far end.
9 plus 3.
Red 9 plus 3 ground, the aircraft has vacated the runway at the far end, proceed Mike 2 on to runway 08 left.
Mike 2 on 208 left, Red 9 plus 3.
Mayday, cargo jet 2397, question.
Alright, that's 2387, heavy tower, got all the red vehicles are coming onto the runway. Do you need any, are you guys vacating the aircraft? 4 plus 1, are you guys able to access them?
Ground, this is Red 5 at the runway. They're off the end of the runway. We're just trying to make access right now.
Red 5, yeah, I understood they're off the end of the runway. Just wondering if you do have access from where you are right now.
9 plus 3, can we go this street with the pilots?
Red 9 plus 3, affirmative. Just stand by, I'll try to see if they're still in the aircraft. Alright, that's 2387, have you guys evacuated the aircraft?
Negative, commercial checklist is still in the aircraft.
Alright, that's 2387. Okay, go to the street frequency now, 122.675. The red vehicles will try to find a path to you. It's a little difficult, I think, with the berm there, but they're going to try to find a path to you as soon as possible.
So the crew remains on board the aircraft, and the ARFF crews are having a hard time getting to the aircraft because it's so muddy out there. They're all going to get stuck if they just go hauling out across the wet grass. But eventually they reach the crew, and the crew gets out of the aircraft uneventfully via the ladder. So if we look a little closer at this timeline, the aircraft touches down about 8:28 after the hour, 29 minutes after the hour. The emergency begins at about 18 minutes or so after the hour. So the crew only has about 10 minutes to sort out this problem. A flap slat asymmetry or disagree can be a rather confusing checklist and can take a little bit of time to get sorted out. Let's take a look. First, a quick review of the Boeing 767 hydraulic system. Your heavy hitters on the 767 are located here on the center hydraulic system, one of 3 hydraulic systems. Any one of these hydraulic systems can operate the aircraft and get the aircraft landed and stopped. But the flaps and the slats are located here on the center hydraulic system. When you lower the flaps on the Boeing 767, the first thing that happens is the leading edge slats begin to droop or begin extending out of the leading edge of the wings. Once you select additional flap settings, then the trailing edge flaps begin to extend. Both these leading edge slats and trailing edge flaps need to extend symmetrically. One of the big hazards in aviation is if you get a sudden flap asymmetry, you're going to get a severe rolling motion to the aircraft. So in order to prevent that, Boeing has a series of brakes that stops the motion of the slats or the flaps in the event that an asymmetry is detected. And so this crew has detected a leading edge slat asymmetry, which would occur just the moment you begin to lower the flaps on the aircraft, and the brakes have fired off and they have stopped additional motion of the slats or the flaps to prevent a severe asymmetry. Now you've got to get into a series of checklists to deal with this problem. This, by the way, is a Delta 767 operations manual found online. It is not mine. It's not my company information. And this is probably an outdated manual. It's for explanation purposes only. Now the aircraft will tell you exactly which condition you have, because again, it's the aircraft that automatically catches the asymmetry and fires the brakes. Is it a leading edge slat asymmetry? A leading edge slat disagree, a trailing edge flap asymmetry, or a trailing edge flap disagree. So once the leading edge slats have disagreed on their position, you want to lock those leading edge slats out and no longer attempt to extend them. However, by using the checklist, you can continue to extend your landing flaps. And you have two ways of getting those landing flaps down, either A, with the normal hydraulic system using the center system hydraulics, or B, with the alternate flap extension using the electrical system. You can electrically lower the flaps like on a Cessna 172 on the Boeing 767, but it is a very slow process. So with the leading edge slat asymmetry, you do not arm the leading edge alternate flap switch, but you can attempt to lower the flaps hydraulically. And if the flaps don't lower using hydraulics, you can lower them using the alternate flap extension via the electrical system. A very slow process. But you're going to still use a considerably higher approach speed. Your reference, flaps 30 reference speed plus an additional 30 knots. Now, as we've learned from previous Boeing 757 and 767 incidents, we've learned that sometimes this leading edge slat disagree malfunction can be the precursor to an even much greater problem with the center hydraulic system or multiple hydraulic systems on board the aircraft. And because this crew was unable to get this aircraft stopped without overrunning the runway by over 1,800 feet using either normal brakes or alternate brakes or even the accumulator brakes, it may indicate to investigators that there may have been something more wrong with the aircraft than a simple leading edge slat asymmetry. So investigators will soon have all the data from the aircraft and the cockpit voice data recorder, and we'll soon have a preliminary report filling us in with a lot more information as to what all went wrong with this flight. And did the crew give themselves enough time to properly troubleshoot this problem? This is not the kind of an emergency that requires immediate action. Like the pilot said, pan, pan, pan. You need to wind your watch and take your time and enter a holding pattern, especially at 1:30 in the morning. It sounded like there were 3 of them on board, and they could have spent some extra time sorting through these rather complicated and convoluted checklists and make sure they've got all their bases covered before coming in to land. Thank you so much for your support of this channel, especially the folks over on Patreon that make this content possible. See you here.